Hello, everyone. Good morning. To authors and invited guests, welcome to Technical Session 7A. Myself, Rishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chair. We have with us Dr. Gitanjali R. Shinde, who has over 15 years of teaching experience, presently working as assistant professor in Department of Computer Engineering at Vishwakarma Institute of Information Technology, Pune, India. She has presented a research article in World Wireless Research Forum meeting, Beijing, China. She has published 50 plus papers in national and international conferences and journals. She's the author and editor of 10 and more books. We welcome you, ma'am. I'd like to start with our papers. We have first K. Shalaja with the paper titled A Novel Explainable Hybrid Framework for Temporal Risk Prediction and Anomaly Detection in Diabetic Disease using Multimodal Health Data. Ma'am, if you're ready, then you may start with the presentation. Ma'am Shalaja, it seems we do not have her in the meeting yet. Our next paper presenter, Vishal Ambure, with the paper titled Access Control Mechanism in Internet of Things, a Comprehensive Survey. Sir, if you're ready, then you may start with the presentation.
Yeah, ma'am. Thank you. Am I audible? Loud and
Yes,
clear?
sir, you're audible. Yes, sir.
Yeah. Thank you. So only give me 1 minute. I will share my PPT also. Just 1 minute, ma'am.
Sure, sir. No issues.
Does my PPT is visible to everyone?
Yes, sir, it is visible.
Yeah. Just give me 1 minute. Yeah. Uh, Good morning, all of you. Good morning, session chair, Gitanjali Shinde, madam. My topic is access control in Internet of Things, a comprehensive survey. My paper ID is 1190, and the authors are Vishal Ambore, Dr. Ketki Shirsagar, and Dr. Parikshit Mahale. Today we are going with the introduction, access control in IoT, access control elements, what is the authentication, authorization, policies, then access control mechanism, what are the challenges in access control, what are the discussions and novelties are possible, and then the references. So we'll go with the one by one. So in this research article, what we have did in this research article, we have gone with the different types of access control mechanisms are present that we have discussed. Then what are the expansion is happening currently in access control based on the resource that we have discussed. Then what are the analysis based on the strength, weaknesses, and application that we have discussed in this research article. Same time we have discussed the what is the elements we require, just like scalability, what are the types are required for the access control that we have discussed. Then we have gone with the new approaches which will be helpful for the future direction that we have discussed. Then we are finding the is there any multiple solution also while we are connecting the different types together, then what is the possibility, and the what is the potential, suppose we are adding this, and then how it will be helpful for the future IoT application that we have discovered in all this research article. So as everyone aware that how the IoT is growing, so IoT is growing continuously everywhere, where we are expecting the number of multiple machines communicating together to collecting the data, analyzing the data. So if you observe what are the threats is here, the first threat is the communication between machine to machine is happening. The second thing is a rapidly change in the IoT applications also, in terms of the smart homes, in terms of the healthcare, in terms of the medicines also, and in terms of the transportation also. But whatever the change are happening, based on that changing, the access control technology is not changing as compared to the change in the application. If you go with the growth of the IoT, so if you observe here, 29.42 billions or millions of the things will happens in a 2030 for the application purpose in the IoT era. So what we are suggesting here, we observe that the IoT is rapidly changing. So this diagram will help everyone to what is the meaning of the access control. So suppose there are n number of users are present here, and that users are expecting some authentication. So nowadays still there are different types of authentication technologies available, but after getting the access with the help of the authentications, there is a less efforts are taken on the authorization. So here, if you are not going with the proper authorization, then it will be damage the partial access, or it will be damage the full access based on the object of the resources. So in a very simple word, the first part is what you require to check that how many users are present. The second part is that you require to go with the authentication of that system. If authentication is a wrong, then the access is denied. But if authentication is a correct, then what you require here is here the research parameter come in a picture. So what you require after access is granted, you require to work research on here. What are the parameters are required for the authorization, so that you can categorize the user, so that you can give the access to the user, either partial or either the full access. So this survey we are focusing on this part, that is the authorization. Then the second one is the authentication, and what is the improvement we require so that it will be helpful for the IoT applications. So here these are the elements while you are going with the access control. So the first very important element is what? Authentication. So you require to the authentication. The second element is what? Authorization. Now the third element, which is also important, the policy. What kind of a policies you are introducing. Then the fourth one is the access enforcement mechanism. Then the fifth one is the scalability, and the sixth one is the device management. So we will go with the one by one, and then I will tell you the what is the novelty we are planning to add, so that the access control will improve their quality. So the first one, authentication. Nowadays, if you observe, the authentication is a one process where you are validating the user, whether you are validating the devices or whether you are trying to validate the services. But what are the current technologies are available? The first technology is available, that is based on the password. So user are introducing or adding the password. Second one is a certificate based authentication. Each device have the some kind of a certification. Based on that, that device will get the authentication. Then the third one is a biometric authentication, which is based on the biometric process. And the fourth one is a token. So generally, if you want to communicate two machines, then there is a token will generate, and then a token encryption and decryption is happening. So this is a the general technology is doing in the authentication. Now the second one, this is our area of interest, is a authorization. After validating that user, my area of interest is that what kind of access I should give to that user. So how to decide that? The first one is that after authentications, I require to that decide the category, which is my first step. Now the second step is what kind of a subject I am considering for permitting, or we can say that the what kind of a resources I am considering. Then the access level. What is the meaning of this access level? There are different types of access level we are deciding. That is a basic level, medium level, or the full level. So I will explain it with a simple example. Suppose that I am the owner and I want to develop the access control. For the owner, I am giving the full access. Suppose any guest come in a picture, so I will give the low access to that system. So how that decided? That all the part is decided based on this technique, which is called as a role. Hello. Sorry to interrupt.
Yes, sir.
Does my PPT is visible?
Yes, it is. Yeah, it is visible.
Yes, it is.
Yeah, sorry. Actually, it is not visible to me. Just only give me 1 minute. Just sorry for interrupting. Just give me 1 minute. I hope now it's visible. Huh. So here what we are planning. Uh,
I'm sorry, sir. Just
yeah, is it visible?
yeah, yeah, it is visible now.
So after deciding the level, I require to the categorize the system. So currently the people are categorizing based on the role base, based on the location base, based on the time base. So authentications is one part, and we are focusing on the authorization part. But what's the challenges nowadays are facing? The first challenge is facing the policies. The developer are planning to implement the policies. Few are already implemented based on the rules, which is called as a policy based on the roles. What is the meaning of the roles? Either user base. So in a user, again, there are a number of categories. One is a owner, second one is a semi guest, third one is a only guest. So such kind of a activity will happen in here. Now second one is a attribute based. So again many people are working on a attribute also. What kind of attributes you are giving, and the third one is based on the context awareness policy. So these three categories are people are using to implement the policy nowadays. Now next is what this is the challenges now that everyone is facing while we are going with the access control mechanism. So what we require while we are implementing the access control mechanism, we require to improve and add and more policies. But what is the problem currently everyone is facing? IoT devices are dealing with the lightweighted system. So if you are trying to add more and more policies and more rules, then the power consumption will improve. The same time, the memories are required is also very large. So what we require the at least some moderate solutions or some balanced solution which will help us to control the access with the some kind of a novelty based mechanism. So what are the novelties that we will discuss? So these are the some parameters for the access control mechanism. Another part, few people already added the novelty in access control mechanism. But what's the problem? If number of IoT devices will improve, then the scalability will change. Why? Suppose initially I have implemented access control mechanism for 10 machines, and suppose I have introduced instead of the 10, I have increases with the 100 machines. So
Excuse me, sir.
scalability will change. Yeah.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Yeah. I will go with the directly my conclusion.
Oh,
So these are the challenges. So the first challenge is what device heterogeneity, because there are different types of devices are connected with each other. Then the resources, what kind of resources are available? Dynamicity, because based on the data, based on the locations, there is a dynamicity is happen. Then the privacy concerns are again come in a picture, and the scalability. So these are the challenges in access control. Then what to do? This is a novelty we are giving. The first novelty is what? Standardization yet not present in access control. So focus some kind of a standardization framework so that it will helpful. The scalability issues come in a picture. So write a policy in a such a way that then the scalability will improve. Then the dynamic environment we require to add. Then the privacy consent, you want to change the privacy consent concern based on the policy rules also. Then the vulnerability in IoT authentication with the more and more security logics, and then the manage access control based on the policy management solutions. And these are my references. So thank you everyone. Okay, ma'am. Thank you.
thank you, sir. Ma'am, would you like to ask any questions? We'll be proceeding with our
Am I
next paper present. Yes, ma'am, you're audible.
okay? So Vishal sir, nice presentation. I
Thank
just
you.
want to know that as you are working on IoT environment,
Yeah.
so are you looking for a centralized access control mechanisms or decentralized access control mechanisms? And the second question is, are you looking only for one-way authentication or you're going to look for two-way authentication?
Yeah. So I will go with the second question. So we are planning here is a mutual authentication, that is two-way. First, we are going with the bi-directional, and after completing that authentication, that is the mutual authentication, then we are jumping to the next part, that is a authorization. So we are planning this for the decentralization system, so that the energy requirement should be the less.
Good. My suggestion is that you can actually take one reference, that is decentralized identifiers and variable credentials. This is
Okay.
the new way of looking for access control. So you can also think about it. So that mechanism you can try for your access control. So, thank you.
Okay, okay. Thank you, madam. Thank you so much. Thanks for the suggestions.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to invite paper presenter Garima Ahuja with the paper titled E-Agriculture and its Applications in ICT for Sustainable Agricultural Development. Ma'am, if you're ready, then you may start with the presentation.
Hello,
Yeah.
am I audible?
Yes, ma'am, I'm audible.
Okay, let me share my screen. Is this visible?
Yes, ma'am, it is visible.
Okay, 1 minute. So, good morning, everyone. I am Garima Ahuja, first year student from Dronacharya College of Engineering, Gurugram. Today, I will be presenting my research on e-agriculture and its application in ICT for sustainable agricultural development, and my paper ID is 1099. So, agriculture is the backbone of the many economies, but it's under immense pressure due to climate change, rising input costs, and fragmented markets. So, hello, is it audible?
Yes, ma'am, you're audible.
Okay, thank you. So, this presentation explores how digital tools are helping farmers work smarter, improve yields, and adapt to modern challenges. So this is the main agenda of my presentation, which includes introduction, literature survey, background and motivation, today's need in agriculture, benefits of e-agriculture, methodology, early detection technologies, intervention tools, global case studies, ethical challenges, AI human collaboration, future detection, and ending with conclusion. So, introduction. So, to understand this topic, I conducted a literature review. So, context of this study is like agriculture today is under pressure from climate change and unpredictable markets. So, the integration of information and ICT, known as e-agriculture, is emerging as a powerful and a useful tool like mobile apps, IoT sensors, AI, and GIS to solve real agriculture problems. And the objective of the presentation is this presentation aims to explore the role of ICT in improving agricultural practices and highlight practical case studies, challenges, and future directions for a scalable implementation. Next, we have literature survey. To understand this topic, I conducted an extensive literature review. I started with over 1,200 research articles and narrowed them down to 20 case studies that highlighted real-world applications. So the focus was on main three regions, India, Kenya, and the Netherlands, each with different levels of digital maturity and farming system. So this diverse perspective allowed me to evaluate ICT tools, that how they perform across both developing and advanced agriculture, environments. Next, background and the motivation. So, farming today is more unpredictable than ever. Erratical rainfalls, floods, and droughts are damaging crops and threatening food security. Smallholder farmers often lack access to high quality inputs, expert advice, or reliable infrastructure. And also, COVID-19 worsened the situation by disturbing the supply chains and labor. This crisis had made it clear that traditional farming methods alone are no longer enough. So, we need scalable and tech driven innovation. Next is today's needs in agriculture. So, today farmers need real time location specific guidance. Uh, we know not one fits all device, so they also need better access to markets, insurance, and financing. Most digital platforms are not designed with smallholders in mind. So, to truly help the farmers, digital tools must be inclusive, working in local languages, functioning offline, and it also requires a minimal training as well. Next, benefits of e-agriculture. So the impact of digital tools in agriculture is already visible. Farmers using AI-based advisory apps see higher yields and fewer losses. IoT tools help save water by automating irrigation. Mobile banking and agri market app allows farmers to connect with buyers and access financial services without relying on middlemen. Also, most importantly, e-agriculture gives farmers the confidence which is backed by the data. Next up is methodology and the main research focus. So my research used a structured literature review. I selected studies with clear data on implementation and outcomes. So you can see the key focus areas, that is early detection of problems using sensors and AI, predict precision advisory systems, access to finance and marketing tools, barriers in adoption, and strategies for scalability and inclusion. Next is, let's talk about early detection technologies. So one of the most powerful use of digital tools is early detection. IoT sensors placed in soil can detect temperature, moisture, and disease stress before it's visible. Also, drones and satellite imagery can identify pest outbreaks or drought zones. Mobile apps with AI can diagnose the crop disease from simple photos only. These tools are helping farmers act early and it also prevent their big losses. So intervention tools. So as we all know, detection is the first step before any precaution or care. So intervention is what which saves the crop. So apps like Kisan Suvidha provide daily crop and weather guidance. AI chatbots like virtual advisors answering questions to farmers 24 into 7. And IVR systems help illiterate farmers by sending voice-based farming tips in regional languages. Also, IoT irrigation system automate watering based on sensor data, which also reduce the water waste and boost the yield. So let's look at how countries are applying these tools. So in India, we have apps like M Kisan and Cropin, which send real-time SMS advice and monitor crops remotely. In Kenya, we have iCow, which supports livestock farmers through SMS, and M-Pesa allows mobile-based savings and loans. In the Netherlands, farmers use drones, AI, and sensor-controlled greenhouse, which is an very advanced model of precision agriculture. So each success story shows that tech works best when it's adapted to local needs. So challenges faced. As digital tools grow, so do ethical concerns. As farmers aware their data is being collected or used, so often the answer is no. They don't know that where the data is actually going, or something mishappening is mishappening must be happen. So AI models can mislead if trained on biased or incomplete data. There's also the risk that only well-off farmers can access these tools, leaving others behind. So, digital farming must protect privacy, ensure
Excuse me, ma'am.
fairness.
I'm
Yes.
really sorry to disturb you, but I'd like to remind you of the time limit.
हाँ जी.
Yeah.
Okay. Next up, we have AI human collaboration. So technology should support, not replace the farmer. So AI may give recommendations, but final decisions still rely on human experience and local knowledge. So to build the trust, platform must be transparent and show farmers why they recommend certain actions. The best system are those where the both AI and the farmer are learning from each other. So future directions and recommendation. So the future of agriculture is digital, but also inclusive and sustainable. We need platforms that combine market access, finance, and weather advice in one space. Also, tools work in low infrastructure areas and support smallholder farmers. Governments, startups, and NGOs should collaborate to scale these technologies in a way that benefits everyone. So, to conclude my presentation, I would like to say that e-agriculture is not just a luxury, it's a necessity for sustainable farming. And the evidence is strong, but the path forward requires the access, affordability, training, and trust. With the right support and inclusive design, we can use technology to empower every farmer from remote villages in India to very high-tech farms in the Europe. Thank you.
Nice presentation, Garima. As this is your literature survey about e-farming, so have you done the literature about the comparison, that is the farmers with the smaller land versus the farmers are having the larger land? So is there
Yeah,
any
I
challenges?
uh, differentiated between the India, Kenya, and Netherlands.
Okay.
हाँ जी.
Again, you need to have you done algorithmic comparison, like for this type of the farming, smart farming, these technologies can be used, or these algorithms are better than that. Have you done that also?
Not yet.
Okay. So you need to pick one of the key parameter, and for that go ahead with that parameter. Nice presentation. Thank you.
Thank you, ma'am.
Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call Krutika Hira Basur with the paper titled Enhancing Healthcare Data Security with Quantum Safe Cryptographic Techniques, E91 Protocol, and AES CBC Integration. Ma'am, if you're ready, then you may start with the presentation.
Good morning, everybody. I'm Dr. Kritika. I'm assistant professor in the Southern University and E&M College. I live in Baton Rouge, Louisiana, United States. So this is one of my funded project. I had mentored one of my student Miss Kohli Bale, and myself and she, we actually designed this project, developed this project. I'll share my screen again. Can you see my PPT?
Yes.
Yeah, thank you. Can you see the screen?
Yes, ma'am, it is visible.
Yeah, thank you. Hmm. So this research is funded by the Board of Regents, Louisiana. And this research presents basically a secure encryption system for the healthcare data using the combination of the quantum key cryptography, that is E91 protocol, and the AES 128 encryption. The system, we actually have used the IBM's Qiskit library to simulate the quantum entanglement and generate the secure keys, which are then used by the AES, the cipher blockchain mode, to protect the healthcare records. So basically, this hybrid method produces the high entropy keys, making it hard to break from the hackers, and achieves a very good the performance. The encryption rate is around the 6.58 megabytes per second, and the decryption rate is around 9.34 megabytes per second, and it is also suitable for the low resistance environment like the IoT and also IoT and also in a medical environment. And it also detects the eavesdropping through the Bell's inequality, and also ensures the quantum level security. Overall, my research shows how the quantum safe encryption can be practically used today to protect the sensitive healthcare information from the future the quantum attacks. So the order of presentation. First, I'm going to explain the basics of my research, the background, related work, and then the proposed work, the evaluation, the performance evaluation, and then few graphs, and then the real world applicability and scalability and future directions, conclusion and future work. And finally, the references. So we all know what is the basic definition of cryptography. It is the foundation of the digital security and also protects the sensitive data from the unauthorized access and the healthcare, basically in the healthcare systems, safeguarding the EHR. The EHR is the electronic health records, the EHR, the telemedicine, and the data-driven inspections. These are very important, and these are the sensitive data that has to be protected. And I have also used the federated learning, the libraries to protect the healthcare, sensitive healthcare records. And the traditional algorithms, the basic traditional cryptographic algorithms are like the RSS, RSA, or the ECC, or and the AES algorithm. They have also protected this data, but advances in the quantum computing are changing this the technology game. That's why the quantum safe cryptographic methods are being used especially for the long-term data security and the quantum key distribution. Okay, here I have used the quantum key distribution. These are the one of the method that uses the quantum mechanics, the entanglement, and the superpositions to generate the keys, to generate the secure keys based on the basis. The bases are like the angles. In a particular angle, the secret keys has to be generated. And this research also simulates the E91 protocol for the quantum key distribution using the entangled qubits measured in the quantum basis, as I said, between the two parties. For example, in this case, I'm using Alice and Bob. Basically, we use these examples in the cryptography. The generated quantum keys are transferred for the AS compatibility and used to encrypt the data further by using the base 64 encoding and SHA-64 the algorithms. And also the AES compatibility are used to encrypt the healthcare data. We are using again the AES CBC, the cipher blockchaining. Basically, a block of data is encrypted differently here in CBC, and the performance matrices such as the entropy and the throughput and the bit agreement rate are evaluated to validate the efficiency and security of this system. Okay. And here in this diagram, it basically illustrates how the quantum technology is transforming the healthcare through the applications like the diagnostics or the precision medicine, and then in surgical assistance and the cybersecurity. Coming to the background and related work, basically, I have referred all these papers and I have listed the techniques used and identified the gap, and then what part I have taken in my research I have listed here. So here, even the Shor's algorithm are also weak in securing the keys. And I have also tried with the BB84 protocol, and it is not basically used for the entanglement purpose. Only E91 protocol is used, and it is more secure compared to the other protocols. So here, coming to the architecture, here in this architecture, in this diagram, basically captures the hybrid cryptographic framework for the healthcare data security. On the left-hand side, we have this classical AES CBC encryption and decryption pipelining using the data set, that is a EHR data set I downloaded from the GitHub. On the right hand side of the quantum simulation, basically it begins with the entangled qubit generations via using the Hammerd and Hadamard and then the CNR gates. This Alice and Bob performs the randomized measurements in the Z and NX basis and filters results based on the matched outcomes. Okay, here. And then the agreed upon bits. Okay, the agreed upon bits are then collected to form a raw quantum key strings, and this basically enhances this key using the SHA 256 hashing, SHA 256 hashing, and then base 64 encoding. These algorithms are again used for the ES CPS compatibility. Like we are providing more security, like a hybrid security to protect the keys. And
Excuse
then,
me, ma'am. I'm
sorry.
really sorry to disturb you, but I'd like to remind you of the time limit.
Yeah, sure.
Yeah.
I'll move to the next slide here. And using these, the outputs, these are the outputs, and then these are the parameters I have used to generate. I'll go through the definition. Some of the variables I have used, I will just mention here. So this slide basically explains the core encryption mechanism of our quantum safe framework. We begin by simulating the E91 protocol distribution key using the Qiskit's AER simulator. Okay, AER simulator is used here. And then the Alice and Bob's share entangled qubit pairs are created using the Hamadard and then the C0 gates. And each qubit pair represents a potential qubit, as I explained. Only when both parties choose the same basis, okay, same basis, then the matching of the keys will be same. The keys will be matched. So these measurements are usually captured by the variables like I have used certain variables here, the q underscore a and then a underscore basis and b underscore basis and the bit string. Okay, some variables I have used to store all these keys and the results. And then we use as I said, base64 encoding process for compatibility, and also have used the Fernet encryption module to safeguard the medical data. And basically, and the performance and security measures are taken care by using these high entropy values. The bit 1.0 is it cannot be changed. That means it is very strong and it is unpredictable. Here, some of the performance measurements, the terminologies are like the entropy. It is basically the measure of the randomness or the uncertainty within the system. And also I have used the bit agreement rate, which is in the context of noise, which is basically a BER, bit error rate. So it is a fundamental measure of how many bits are incorrectly received compared to the total number of transmitted bits through a communication channel. And then I have also used the quantum bit error rate. It basically measures the probability of the mismatch between the signal sent and the received in a quantum communication environment. Sorry, I forgot to mention here the throughput is this is the formula I have calculated. So the data transmitted by the execution time, and this is the result I have got. Sorry, this is a decryption rate and this is the encryption rate. And then the quantum key distribution, these are the entropies values. And in the bit agreement rate, and this is the formula. Here, the M is the total number of bits and the T is the total number of entangled pairs. And also the quantum bit error rate is basically measures the probability of the mismatch between the signal sent and the received in the quantum communication environment. And this is the formula used. And it is below this 11%. That means it is in a good state. And here, I have generated these graphs. So basically this graph plots the individual bit values of the simulated quantum key across the 30 positions and highlights their distribution. In each point corresponds to either 0 or 1 with the values which are scattered uniformly, indicating low bias and then high unpredictability. Okay. And also this entropy behavior validates the E91 simulation reliability for producing a post-quantum safe encryption keys. And I have also got this graph here. It is based on the bit error rate over the trials with the simulated noise. This graph basically captures the bit agreement rate across the 10 trials with the added quantum noise. And this quantifies how Alice and Bob measurements match when the identical with respect to the identical basis, even under the imperfect conditions. For example, if I toss a coin, if Alice and Bob are both entangled, if Bob receives the head, and immediately Alice know that he's on the trial. Okay, head and trial. Yeah. And then this graph basically represents the quantum bit error rate fluctuations across the 31 simulation trials under the controlled quantum noise. Each value basically represents the proportion of the this mismatch bits between the Alice and Bob when using the identical measurement basis, and the stable regions with the low Q BR confirms effective quantum communication, supporting the robustness of this the E91 protocol. And this table showcases basically the time complexity behavior of the key components of the quantum cryptographic framework. And here I have mentioned the metrics and values here. And I would like to conclude that this research successfully integrates the E91 based quantum key distribution with the AES 128 encryption for this secure healthcare data. And the quantum simulated key basically it exhibits basically the strong entropy and then the agreement rates, and it is validated by the AR simulator and then the Bell equality. It is basically a tool to measure this entanglement, and the keys were transformed using the SHA 256 and base 64 to these are used for the Fernet encryption. And the performance metrics just confirm that the minimum computational overhead and reliable throughput during the encryption and decryption process, and the encryption rate and the decryption rate is it is more accurate and it is less. And then the coming to the future work, by including rekeying and then secure refresh protocols, these are the two main protocols, but it is also not used for the entanglement. And basically, the key rekeying and the secure refresh protocols, it basically manages encryption key life cycles. We'll also scale down the framework for the multi-user environments using the quantum key relays and then synchronization channels. Um, and also, we would like to concentrate more on the quantum error correction and then the entropies to make it the key. We would like to make it more stronger, and also benchmarking in future. The benchmarking against the NIST algorithms also we are looking for, and these are the references. Okay, thank you for giving me this opportunity.
Actually, very nice work, ma'am. I'm happy to hear your work. I just want to know that the framework, E91 protocol framework, is there any limitations for that? If we are going to compare it only for the healthcare system?
No, there are no limitations. Um, as for my knowledge, the BB84 had more like limitations compared to the E91 protocol. And then yeah, one of the limitation is it cannot be applied for the multi-environment settings. That is one of the limitations. So in this case, we actually we want to use include rekeying and then secure refresh protocols for the multi-environment setting.
Okay, thank you, ma'am.
Thank you.
Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to invite paper presenter Suprit Hatti with the paper titled Exploratory Data Analysis of Alzheimer's Disease, Risk Patterns and Regional Impact. Sir, if you're ready, then you may start with the presentation.
Yeah, ma'am. Am I audible?
Yes, sir, you're audible.
Yeah. Can you see the PPT now?
Yes, sir, it is
Yeah.
visible.
Yeah. Mm. Good morning, everyone. I am Supreet Hatti from KLE Technological University. I'm a final year engineering student. Um, Today, I am here to present the paper titled Exploratory Data Analysis of Alzheimer's Disease, Risk Patterns and Regional Impact. This work was conducted in collaboration with the authors PG Sunita Hiremat, Manohar Madgi, and Neha Taranum Pendari. And we also thank ICT4SD for accepting our paper and organizing team for this opportunity. So this is the agenda for today's presentation. We'll start with introduction and then problem statement and objectives, then literature survey, then methodology, then conclusion, then future work and references. Um, to begin with introduction, Alzheimer's disease is the most common form of dementia, which accounts 60 to 70% all cases worldwide. It affects over 6.5 million of Americans aged 65 and above, and its societal burden is rising rapidly. What makes Alzheimer's particularly challenging is that there is no known root cause or cure. It progressively or gradually increases and it is irreversible. This makes early detection and risk factor understanding especially important. Our study is step towards that goal. We aim to analyze how Alzheimer's related cognitive decline varies across US regions and how it's influenced by age, gender, and comorbidities like diabetes or depression. So this was the problem statement, and these are the objectives for our study. Um, Cognitive decline, which is measurable decrease in memory and thinking ability, is a key early symptom of Alzheimer's. However, it doesn't appear equally across population. Factors like chronic illness, mental health, and lifestyle may accelerate the risk. Our goal is to investigate how these factors vary, demographics, and whether any consistent risk patterns can be identified across the time. So our objectives were to analyze regional, gender, and age-based disparities in Alzheimer's prevalence using BRFSS data, to identify the key risk factors in diabetes, depression, and cardiovascular influencing cognitive decline, to uncover temporal and geographic patterns that inform future predictive and explainable AI models. We conducted the literature survey to ensure there was a relevant past research done on this topic, and we continue to contribute more to this topic. Um, Studies by Nguyen and Betsy emphasized the link between insulin resistance, diabetes, and Alzheimer's progression, even calling it the type 3 diabetes in some papers. Works by De Paula and Cipriani explored how cardiovascular health and depression play a role in accelerating cognitive decline. Age and disparities were also documented. Females and individuals over 65 are more prone to Alzheimer's, a trend we aim to validate at a broader scale. A major gap in the literature was that the most studies were clinical and localized, lacking regional population level insights. This motivated our use of the BRFSS data, which is public stratified and regionally representative. The grouped nature of the data made classical statistical methods like p-values less suitable, encouraging an exploratory visual first approach. So the literature helped shape our direction, risk factors focus, and analytic approach, allowing us to contribute where prior work was limited. Uh, so to begin with methodology, we start with dataset description. The dataset represents the group level health record, not individually stratified by age, gender, race, and region. It includes 39 health related questions covering cognitive decline, physical health, and comorbidities. The dataset contains 2,50,937 rows and 33 columns, which focus on demographics and dementia-related questions, outcomes. The dataset was collected from Behavioral Risk Factor Surveillance System, which is an organization in USA which collects the data by through telephone, calling the people individually. The dataset was collected from 2015 to 2021 across 59 US locations. Missing values in key fields were imputed using mean-based methods, and redundant attributes like geolocations, IDs, meta fields were removed to reduce noise and dimensionality as for the pre-processing. To begin with analysis and visualizations, we'll start with the regional prevalence of dementia. Um, uh, so we analyzed the regional patterns of the reported cognitive decline. The Midwest showed the highest prevalence, followed by the West and Northeast. In contrast, the Southwest reported the lowest, which might reflect underreporting and health access disparities. This set the stage for understanding whether the health system strength impacts the diagnosis rate. The next analysis was demographics of the cognitive decline. The first plot here shows the gender-wise distribution by the region. From this plot, we can see that the females are most affected by the Alzheimer's disease. This was also mentioned in one of the papers we referred to, and it is a well-known fact that females are more affected by Alzheimer's than compared to males. And the next plot here shows that the age-wise distribution by the region. This plot shows that there is overall age group was affected by most by the Alzheimer's disease. Overall age group here includes mostly people aged between 40 to 70, which is like an average value for the Alzheimer's disease patients. And the next graph here shows that the cognitive decline over the years for all the regions. It shows how cognitive decline changed from 2015 to 2021. A striking spike is seen in 2017, especially in the region of Southeast, and also the West peaked slightly in later in 2019. These spikes may be linked to public health trends, awareness campaigns, or rising comorbidities in those years. These are the temporal risk factor trends in Southeast and Northeast from 2015 to 2021. These are the two high prevalence regions. In both, cognitive decline spiked alongside the conditions like diabetes, CVD, depression, and asthma, particularly around 2017. The next plots are of cognitive decline and risk factors in Southwest females aged 50 to 64. Mm. The subgroup females aged 50 to 64 in the Southwest showed an unusual rise in decline. It correlated with the rising smoking, asthma, arthritis, diabetes, and CVD. This highlights how chronic disease clustering in younger elderly women can accelerate cognitive issues earlier than expected. And this is the risk factor heat map. This shows the correlation between risk factors and the cognitive decline across all regions. Diabetes was the most consistent and strongest factor, with CVD, asthma, and smoking also showing moderate to high association. It reinforces that the Alzheimer's is not isolated. It is tightly linked to metabolic and behavioral health conditions. To conclude, I would like to tell that Alzheimer's prevalence is influenced by region, age, and gender. and females and older adults are at most risks when it comes to Alzheimer's. Diabetes stood out as the strongest risk factor, followed by CVD, asthma, and smoking. This analysis reveals that health clusters and hotspot guiding targeted prevention strategies are important. For future work, um, uh, we are we have thought of using explainable AI models like SHAP or LIME to interpret feature impacts, creating region-specific models for localized prediction, and extending individual level patient data if available. Also, the data of Indian Alzheimer patients is not readily available. If we delve into it or if we somehow collect it, it would be really helpful to create a model that predicts um, the Alzheimer's prevalence in India, including lifestyle and environmental factors like sleep, pollution, and diet. Evaluating temporal shifts post 2021 using fresh BRFSS data for ongoing monitoring is also an aim for our future work. And these are the references. And thank you. I'm open to questions.
Nice presentation.
Thank you, ma'am.
I just like to know about data set. Have you done any data processing or data validation?
I have done data set processing, ma'am. So the data set was based on 39 questions, and it was divided into 59 locations. I grouped those values into 6 locations, so that I can if I can do the analysis easily. A validation, in case of validation, there is no another data set to compare it with, so I could not do that, ma'am.
Okay, thank you.
Thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to invite paper presenter Anushka Kurundale with the paper title Fake Review Detection Using LSTM and BERT. Ma'am, if you're ready, then you may start with the presentation. Ma'am Anushka?
Yes, ma'am. Am I
Yeah.
audible?
Yes, ma'am, you're audible.
Am I visible to you?
1 second, ma'am.
Screen is visible to you,
Yes, ma'am,
ma'am?
it is visible.
Okay. Now I'm going to start my presentation. Hello, good morning everyone. My name is Anushka Gurandale. Today I will be presenting our research work titled Fake Review Detection using LSTM and BERT model. My co-authors are Sakshi Kuite, Kiran Mani, Snehal Nale, and Dr. Reshma Totre. So, in these presentations, I will briefly walk you through the motivation, objective, scope, literature survey, hardware, software requirement, data flow diagram, system architecture, use case diagram, methodology, result, conclusion, and references.
Excuse me,
So,
ma'am. Could
hello?
you please put your presentation in slideshow mode?
Yes, ma'am. Now it is visible?
Yes, ma'am, go ahead.
Okay. So, in today's digital landscape, online reviews have a significant impact on customer decisions, especially in the e-commerce sector. So, fake reviews distort customers' perceptions, often leading to the poor purchase decisions and impacting the business credibility also. To tackle this issue, we make use of both LSTM and the BERT models. LSTM is the long-term short-term memory model and BERT is the bidirectional encoder representational transformer model, allowing us to benefit from the unique capabilities of each. LSTM helps capture sequential dependencies in text, and while BERT model provides contextual understanding in data, in sequential data, and enabling the detection of the subtle patterns indicative of the fake reviews. Our model is designed to detect fake reviews and with the different contexts, enhancing the applicability in regional markets and aiming to promote more trustworthy online reviews ecosystem. So, in motivation, online reviews significantly influence customers' decisions across various platforms, from e-commerce website to service providers. So fake reviews are becoming more common, which can mislead people, harm business reputations also, and disrupt the fairness of the market. Detecting the fake reviews has become a critical task to ensure the integrity of online information and maintain customer trust. So these reviews can be cleverly crafted to mimic genuine user feedback and also making them difficult to identify using the conventional techniques also. To solve this problem, advanced deep learning methods like LSTM and the BERT models can be used to make fake reviews detection more accurate, helping to create more trustworthy online platforms. So objective of our project is that identify patterns in fake reviews, analyze and understand the linguistic and behavioral patterns also commonly found in fake reviews. And second is the implement LSTM and BERT models. We have passed all the five objectives in our work. So third is enhanced detection accuracy. We have also enhanced our detection accuracy by using the accuracy metrics like F1 score, accuracy, precision, recall. All these accuracy metrics we have used. And fourth is the evaluate model performance. To evaluation of the model performance, we have used these metrics. And fifth is the create user friendly interface. So design a system or tool that allows users to easily detect fake reviews on the different platforms. Scope is that application in various industries. The project can be applied to multiple industries, including e-commerce industry, hospitality, and service-based platform also, in restaurant websites also, where customer reviews significantly influence business outcomes. Adaptability of multiple languages. We have also used multilingual model to use multiple languages in that reviews. So scalability, integration with existing system. These are the scopes. And in this literature survey work, so we have studies the our literature survey is covered several recent work from the 2022 to 2024 paper focused on the traditional machine learning models achieving 90% accuracy. So, but struggle with generalization and the resource constraints. Later research introduced hybrid deep learning approaches such as CNN LSTM approach, LSTM RNN approach, which has improved their accuracy also. But from this analysis, we identified the gap and the accuracy model also, which motivated us to propose the model which combine both LSTM and the BERT models. So these are the hardware software requirement in which we need the Intel i5 or the higher processor, 8 GB RAM, 16 GB recommended, SSD at least with 56 GB free space, optional GPU because there are the very large data set. So, but we have solved this problem by using the pre-10 BERT model. The software requirements are the operating system Windows 10 or higher we have used, and development environment in which we have used Python 3.8 version and IDEs such as Visual Studio for the editor. So this is the data flow diagram. In this data flow diagram, there is the flow of all the work we have done. So first we have taken the input data, and this input data is going into the pre-processing to pre-process the data. In the pre-processing, we have done the stop word removal, punctuation removal, and the stemming also. In stop word removal, it removes the stop words like the, which is not useful in the fake review detection. So these unuseful words, it is removed in the stop word removal system. In punctuation removal, all the punctuation marks are removed. And in the stemming, there are, for example, word is the continuous. So it will convert continuous into only the continue, only the root words it will save in the data set. So all this data is converted into the pre-processed data, clean data, all the unstructured data we converted into the structurized format for the better model accuracy. So this data is going into the then feature selection. In the feature selections, we have identified the relevant feature, relevant patterns by using these models for the better pattern understanding. So we have used also TF and NF version also. So model development, we have used two models, LSTM and the BERT models. First, we have trained the model, then validate, and after that, we have find the accuracy of the models. Which model has the greater accuracy, then result will be displayed on that particular model. So after that, performance calculations, for the performance evaluation, we use the metrics like F1 score, accuracy, recall metrics. In the system architectures, the same like I have told on data flow diagram, like data acquisition, then pre-processing is done, then after that cleaning, data cleaning and feature selection, then model training, model development, and then performance evaluation and result will be displayed. So this is use case diagrams. All the activities is done from the user to server, user end to server end. You display here like user first need to authenticate this user. So first in authentication, user need to register or log in into the fake review detection page. But if user enter wrong credentials, then user come back into the login and the registration page. User need to enter the right credentials. After that, there is user has to enter the reviews which user want to check if it is genuine or the fake. Then after that, the model at the server side, the model is do its work like it checks the fake reviews. It ensure that this is the fake or the genuine. It does some model development techniques like we have used both LSTM and the BERT for that. So in methodology, first we have used the data preparation method. In that we have first in data preparations for our project we have used a basic English language. We have used multilingual technical, so we can enter our reviews in any language. But at our model in we have used the English basic language. So in this first data is converted into the English language, then it will be done other the model development process. In the pre-processing we have done tokenization, removal of special characters, lowercase conversion and padding of sequence also. So in model architecture we have used LSTM model, long short term memory model, neural network models. In that are the layers of the LSTM and the BERT models. So in BERT is the bidirectional encoder representational transformer model. This is the transformer model which handles the sequential data from the left to right and right to left also. That's why it is called as the bidirectional model. So in the training and the evaluation, so in the training, train using binary cross entropy loss and Adam optimizer, class imbalance handling, class weights were adjusted based on the review disruption. So evaluation matrix, accuracy, precision, recall, and F1 score. But we got higher accuracy in the F1 score, so we have concluded that F1 score will be the presented on the screen. So F1 score has the 93% accuracy and others are the 88 to 89% accuracy. And the overfitting prevention also we have done early stopping based on the validation loss. So to minimizing the epoch size, we have done the overfitting prevention problem also solved. So explainability, integration, why we have used BERT model act like the black boxes. Lime makes them interpretable, highlights most important words contributing to prediction, generates scrollable bar charts showing each word's weight in classification, integrated with the front end for real-time user feedback. So in user interface, we have used these front-end technologies like HTML, CSS, JavaScript, which futuristic NeoGlow, particle background design, etc. to look website good. So we have used this styling sheet, etc. So in login or sign up authentication, we have done in the user interface. Review input box for users is also there. Instant classification is done. The review which is fake or genuine, which is also done. Scrollable line explanation is done. Why this review is the fake, each word by word explanation is also done in our work. So these are the results. The model achieved an accuracy of the 93.19%, demonstrating its overall ability to correctly classify reviews. The precision was 88.59%, meaning that the model was effective in minimizing false positive, correctly identifying genuine reviews. As such, the recall stood at 89.80%, reflecting the model's capacity to detect most fake reviews. And F1 score, which balances both precision and the recall, which is calculated as the 93.19, showcasing a well-rounded and reliable classification performances. These results validate the effectiveness of deep learning approach in capturing both the contextual and the sequential nonsense in the reviews text. So these are the charts in the confusion matrix, which is the performance evaluation tool used for the classification problems in machine learning. So in that confusion matrix, there are the four parameter terminology we have used in the confusion matrix, which are the four parameters are true negative, false negative. True positive is the model predict positive and it is actually positive. True negative is the model predicted negative but is actually negative. And the false positive is model predicted positive and it actually negative, and false negative is model predicted negative, it is actually positive. So with the help of the confusion of matrix, we have also evaluated the performance. So in conclusion, I like to conclude this presentation here. In fake reviews are a big problem for online platforms and can harm customer trust. This project tackles the issue by using advanced AI models like LSTM and BERT model to identify and filter out the fake reviews more effectively. By doing so, we aim to make reviews systems more reliable, helping customers access genuine feedback. The successful completion of this project not only helps protect both consumers and business, but also adds to the progress in AI and natural language processing for fighting online fraud. So these are our references. Thank you.
Uh, my presentation. I just want to know that as you are doing for fake reviews, so have you considered reviews which are given sarcastically? So have you classified sarcastic reviews from the fake reviews?
I'm not able to hear, ma'am. Please, sorry, can you ask again?
As you are doing the for reviews, so in reviews there are the category also that some people may give review sarcastically. So sarcasm part have you considered while considering fake reviews and genuine reviews?
Yes, ma'am. We are consider that sarcastic reviews also, and we are trying to solve these limitations also, because in the previous papers also this is the very big limitations for judge for finding the genuine and the fake reviews. So we are also considering that limitations, and we are overcome that also by considering that, and in our data set these reviews are also considered.
Okay, thank you.
Thank you, ma'am.
Thank you, ma'am. We will be proceeding with our next paper presenter. I'd like to call upon Mehak Sayed with the paper titled IoT-based crime prevention system, a modern surveillance approach. Ma'am, if you're ready, then you may start with the presentation.
Yes, ma'am. I am audible?
Yes, ma'am, you're audible.
Yes. Can you see my screen, ma'am? Visible?
Yes, ma'am, it is visible.
Good morning. Myself, Mehak Sayed. I am a third year student from Vishwakarma Institute of Technology, Pune, and our topic is IoT-based crime prevention system. Along with authors Dr. Ajay Talele, Siddhi Shinte, Om Gaikwad, Sai More, Pooja Nanavre, Ashwini Borole, Pratiksha Bile, and Bharat Bangar. And our paper ID is 1158. So here are the index, what we will cover, the introduction, understanding IoT in surveillance, system components, working mechanisms, smart cities and AI integrations, case applications, advantages, challenges faced, conclusion and references. Introduction. Crime is a serious issue across the world, and traditional systems often only act after something has happened. We wanted to explore how technology, especially IoT, can help us take a proactive approach instead of a reactive one. Uh, uh, so understanding IoT in surveillance, here are the three factors, that is IoT connects devices for seamless data exchange used to monitor environments in real time. Uh, excuse me. Am I audible?
Yes, yes.
Hello.
Yes, ma'am, you're audible.
IoT, or the Internet of Things, refers to devices that collect and share data with each other. In the context of surveillance, this means things like sensors and cameras working together in a real time to detect unusual activity and alert authorities instantly. So here are the system components. Our system is built with the smart sensors for detecting motions or a sound, AI-powered CCTV cameras, and devices like RFID cards for access control. All of this works together with the central system that analyzes the data and acts quickly. So here are the working mechanisms. Here's how it works. If any sensor detects suspiciously activities, says a loud noise or a movement at an odd hour, the system sends the data to an AI module. If the AI sees it as a threat, it immediately sends an alert to the concerned department. No delay. This will prevent the unusual behavior or unusual instance happening in the surrounding. Smart cities and AI integration it covers. We also look into how the system fits into smart cities. In many places, AI is already being used to identify faces, predict crime hotspots, and manage access to secure areas. Combining AI with IoT makes the system smarter and more efficiently. Uh, One of the examples are the IoT based the crime scene detection held in our areas. Smart cities and AI integrations. We also looked into how this system fits in. Uh, so here are the some example, that is AI enabled facial recognition in CCTV, predictive policing using historical data, smart access control in sensitive zones. Case applications. Some real life example include surveillance in metro stations, AI enabled monitoring during festivals, and smart policing control rooms. This system reduces the time it takes to react and improve safety during a large gathering. Uh, Advantages, that is automated 24/7 surveillance minimizes manual errors, speed up crime detections and response, improves overall public safety. The biggest benefits: first, it runs 24/7 with a minimal human effort. Second, it responds faster than a manual systems. Third, it reduces the chances of a human error and overall makes public places safer. Challenges faced are data privacy concerns, initial setups and maintenance costs, network and power reliability, need for trained personals. Of course, that are these are the challenges. Data privacy is a major concern. The system needs a stable internet and a power supply. Plus, setting it up can be expensive, and people need training to use it efficiently. So here is the conclusion. IoT is reshaping modern crime prevention strategies. Combining AI and IoT leads to smarter surveillance. Ongoing innovations and ethical use are the key to success. There are challenges, data privacy. Sorry, to sum up, IoT has a huge potential in a crime prevention. When paired with the AI, we can move from just watching to actually predicting and preventing crime. It's not just about technology, it's about building safer community. And here are the references. Thank you. Hello. Hello.
Hello.
Yes,
Yes, you
ma'am.
are audible. Just check.
Ma'am, I'm not able to hear you. Hello.
Yes, ma'am.
Ma'am, I'm open to questions.
Hello. Yes, can you just
Yes, ma'am.
tell me about your future work? Am I audible?
Yes, ma'am. The future work can be just like in a it will be a predictive policing case and smart CCTVs in London. It can also be helpful in Indians, means in India. If we fix the smart CCTVs, so it will be enable us to get the crime scenes more earlier.
Okay, thank you.
Thank you.
Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to invite paper presenter Sambram with the paper titled On Location ADR Recording Advancements and Challenges in Real-Time Dialogue Replacement. So if you're ready, then you may start with the presentation. Sir Sambram? Yeah.
Ma'am, good morning. I am here. Let me try first. Three. 1 minute, ma'am. I just
Sure, sir.
seconds, please.
Sir, your screen is not visible. Hello.
So your screen isn't visible yet.
Yes, ma'am. I'm just getting the PowerPoint, please.
Okay. So if it's taking a lot of time, we could take up the next presenter and then you can present your paper, if that's all right.
Ma'am, that will be better. I'll be and I'll fix it, ma'am. Thank you.
So we'll be proceeding on with the next paper presenter. I'd like to invite paper presenter Mario Castro with the paper titled Review of Routing Protocols to Improve Quality of Service in SDWSN. So if you're ready, then you may start.
Yes, thanks so much. Give me a minute to present my screen.
Sure, sir.
Uh, I'm I'm sorry. It is visible my presentation.
Yes, sir, it is visible.
Thanks so much. Hello, my name is Mario Castro Romero, and it is a pleasure to present our work title Review of Routing Protocols to Improve Quality of Service in Software-Defined Wire Sensor Networks. This research was conducted in collaboration with Dr. Carlos Ernesto Carrillo Arellano and Dr. Leonardo Daniel Sanchez Martinez. Our goals were to identify current trends and key developments in this field, analyze the strengths and limitations of existing solutions, and highlight open challenges for future research. In this presentation, I will briefly explain the motivation behind our work, describe our review methodology, and present the most relevant contributions and conclusions. Traditional wire sensor networks operate in a fully distributed manner where each sensor nodes make local routing decisions. While simple, this architecture presents challenges in terms of ensuring quality of service, as each node operates in isolation without global coordination. In contrast, software-defined wire sensor networks introduce a centralized and programmable architecture where the controller has a global view of the entire network. This allows for dynamic, coordinated decision and adaptive quality of service mechanisms that traditional wire sensor networks cannot easily achieve. Such programmability and centralized management open opportunities for improved performance, flexibility, and intelligent network control, critical for applications like smart cities, healthcare, or precision agriculture. Some key features that make software-defined wire sensor networks a superior alternative include control programmability, which enables the dynamic and adaptive definition and application of quality of service policies, responding to both application requirements and changing network conditions. Traffic prioritization, which allow data flows to be classified according to their criticality or priority levels. This ensures that high priority packets, such as emergency or urgent data, are delivered with minimal delay. Congestion management can be improved by using the controller's full view of the network. It can detect busy areas and adjust the data paths to keep the network working well and avoid losing packets. Failover mechanisms. In the event of a node or link failure, the centralized controller can recalculate and implement alternative routes in near real time, improving network resilience and minimizing service disruption. For our literature review, we use SiteSpace, a powerful bibliometric and visualization tool created by Dr. Chaomei Chen. This tool helps to identify trends, research clusters, and influential authors through co-citation, analysis, and network visualization. The SiteSpace application ensured that our review covered not only classical contribution, but also the most recent and impactful studies on software-defined wire sensor network routing and quality of service. Our review identified several relevant research and development strategies, such as artificial intelligence-based routing. This is becoming increasingly important by applying reinforcement learning, neural networks, and deep learning. Researchers aim to create the adaptive, intelligent, and self-optimizing routing strategies. These techniques allow the network to continuously learn and improve routing decisions over time. Energy-aware and quality of service-centric heuristic, where the focus is on designing algorithms that minimize energy consumption while optimizing key quality of service metrics such as latency, reliability, and throughput. Real-world implementation and prototypes, these efforts go beyond simulation by implementing software-defined wire sensor networks protocols on platforms such as Raspberry Pi devices or IoT testbeds, demonstrating their practical viability. We also see advances in multi-objective optimization techniques, which simultaneously balance multiple criteria such as energy efficiency, delay, congestion levels, and link quality to meet increasingly complex quality of service demands. Finally, simulation and modeling tools remain fundamental. Platforms such as MATLAB, NS3, OmNet++, or Mininet Wi-Fi are extensively used to rigorously test, validate, and fine-tune proposed algorithms before moving to real-world trials. I will briefly highlight key contributions instead of listing all details. First, Kumar et al. 2019 proposed a heuristic-based approach named OLA-T. Their main objective was to achieve traffic engineering while maintaining low energy consumption. This work is a clear example of energy and quality of service-centric heuristic development. Qui et al. 2019 combined Elman neural network with hierarchical clustering to enable intelligent dynamic load balancing in a smart city application, representing a strong case of integrating artificial intelligence with hierarchical network architecture for routing optimization. Jin et al. 2019 developed a hierarchical interference-aware routing algorithm known as IERA. The primary goal was to achieve energy-efficient routing while also considering interference patterns within the network. Jonas et al. 2021 present a reformed learning-based routing protocol aimed at dynamically minimizing energy consumption. They implemented their test bench on a Raspberry Pi platforms, demonstrating the viability of AI-driven solution in real-world environment. Let's now examine the final group of studies summarized in this table. Hyan et al. 2022 proposed a multi-objective routing algorithm designed to achieve load balancing while meeting quality of service requirements. These words exemplify an energy and quality of service centric heuristic strategy. Moving on, Huang et al. 2022 introduced a control scheme based on deep graph reinforcement learning, combining graph convolutional networks with deterministic policy gradient methods. Their objective was to optimize delay, buffer occupancy, and distance to the destination. To conclude, let's briefly explore some of the most promising future research directions in software-defined wireless sensor network routing. First, large-scale real-world deployment are crucial. While simulation and test beds offer valuable insights, only real deployments can validate performance under dynamic and unpredictable conditions, revealing challenges not apparent in controlled environments. Second, integration with emerging technologies such as 5G, edge computing, and blockchain offer exciting opportunities to improve responsiveness, scalability, and security, complementing the flexible and centralized nature. Another critical research line is the development of standardized frameworks and protocols to ensure interoperability among heterogeneous devices and vendors, facilitating practical large-scale adoption. Additionally, exploring advanced artificial intelligence models, including deep reinforcement learning, can take routing decisions to a new level while preserving user privacy. Overall, these future research directions demonstrate the enormous potential of software-defined wireless sensor networks to evolve and meet increasingly demanding applications for smart cities to precision agriculture and beyond. Before closing, I would like to express my sincere gratitude to my co-authors and the Universidad Autónoma Metropolitana Unidad Azcapotzalco for their invaluable support throughout this research. I would also like to thank the scientific community whose work provided the knowledge base for this study. That concludes my presentation. Thank you very much for your attention. I will now be happy to take any question or comments you might have.
Nice presentation. I just want to know that if we are going to use the AI-based routing algorithms, then what can be the challenges and what will be the performance criteria for that?
Um, there are a lot of algorithms that we review, but the most interesting are some that have a relation with intelligent and artificial intelligence.
Okay, thank you.
Thanks.
Thank you, sir. We'll be proceeding on with our next paper presenter. I'd like to invite paper presenter Manpreet Kaur with the paper title Waste Classification with Convolutional Neural Networks, a comparative study of various models. Ma'am, if you're ready, then you may start with the presentation.
Hi, I am audible.
Yes, ma'am, you're audible.
Okay. The screen is visible.
Yes, ma'am, it is visible.
Just a second. Hello everyone, my name is Manpreet Kaur and I am present here to tell you about our recent research that we have done, which is waste classification with convolution neural network, a comparative study of various models. And this research is being done with collaboration with other authors, Naman Jain, Neeraj Gupta, and Gitanjali Bola, and we all are from DTU. And we aim to address a very real world problem with modern AI solution, which is waste classification. So let us see what is the motivation behind this project, like why we are doing this. As we know that, the cities are growing continuously and consumption rate is being increasing day by day, due to which the solid waste is expected to reach 3.5 billion tons by 2050 as per World Bank. And there are some traditional waste sorting practices which are more labor intensive, but they do lead to some of the errors and health hazards. And this improper waste management contributes to environmental degradation, pollution, and low recycling rate. Our belief is we cannot manage what we cannot classify. Now the problem statement is we wanted to automate the waste classification reliably using deep learning models. And now there are some questions that we address while doing this research. Which CNN architecture will be best for this track? Can this model run efficiently on real-time data or on low resource environment like Raspberry Pi? And we have designed, compare, and evaluate different CNN models for the multi-class garbage classification using the real world images, using the real data set that we have. So the usefulness of our research, the research has both environmental as well as technical relevance. Environmentally, it will improve the recycling rate and reduces the misclassification error. And technically, we have benchmarked 6 different CNN models. We have also considered the efficiency versus accuracy trade-off. And we came to know how we will use these models for real-time applications. So like for municipal dashboards, or how to use this on Raspberry Pi and other systems. Now the data set that we have used for our research is the RoboFlow garbage classification data set, and there are 6 different classes. So like we have biodegradable waste, we have paper, we have cardboard, plastic, glass, metal, etc. And the data set comprises of above 17,000 images, and we have splitted the data set into 3 splits, which is 82% training and 12% validation and 6% test. And why we have chosen this particular data set? Because it's very reliable, and it gives us most real time images, like it gives us lightening, contrast, and things, etc. Now the overall approach for our project, what is the overall approach? So we have done the data processing. Like I said, we have 1700 plus images. And in order to normalize, in order to equalize every image, we have turned that particular image into 224 into 224 pixel. We have also done normalization, and we have used techniques like flips, rotation, brightness comparisons, etc. We have done all these things in order to journalize our model so that there are very less chances of overfitting. The model selection part is we have used 6 different models: EfficientNet family, MobileNet V2, ResNet 50, and VGG16. The EfficientNet family is known for its scalability. The MobileNet V2 is very lightweight model. ResNet is known for its residual connection, which help it to overcome the problem of vanishing gradients. And for VGG16, it is a baseline model with large parameter count. For training and optimization, we have used Adam Optimizer with a learning rate of e to the power minus 4. Batch size is 34 with over 20 epochs. We have also used our loss function, which is the categorical cross entropy. After that, we have our evaluation matrix, where for each model we have calculated the accuracies across 3 splits. We have precision, we have recall, F1 score. Confusion matrix is there in order to pinpoint the misclassification. Then we have this trade-off between number of parameters and accuracy. And finally, the comparative analysis is being done using all these matrices that we have calculated. Next is, let us talk about the model accuracy versus epoch. So we have mapped the accuracy with epochs, and we came to know that we have marked here the training accuracies, which is like these lines, and then we have these validation, which is marked with these crosses, and then we have these testing accuracies. And combining everything, we came to know that okay, we the efficient net b naught is one of the best model amongst all. And other models like like mobile net and BGG16 and ResNet, they also perform well, but they seems to have this overfitting nature. Like while training, they seems to have this overfitting nature. And by doing all this evaluation classification, we came to know that efficient net b naught is one of the best model as compared to all of those, if we talks in terms of accuracy, precision, and reliability. Now, this is the model which is introduced by Google in 2019, and the garbage data set has like 1700 above images. So this goes like, so we have like I said, we have splitted the data set into three different splits, and then we have trained our model. Now model is something like they have input layer, then convolution layer, then we have dense layer, global average pooling, dropout layers, etc. And we have trained the model, so whenever we are giving it any of the image, it will predict out of 6 classes, okay, the image is glass, biodegradable, paper, etc. This is how the efficient net B naught works for our research, for our project. Next is we have also evaluated the metrics, like we have evaluated the test accuracies, training accuracies, average precision, recall, F1 score, everything for the 6 models. And we came to know that for when we collectively see everything, we came to know that efficient net B naught gives us one of the best metrics as comparison to mobile net V2 and ResNet. We have good training accuracy, which is 100%, and the test accuracy decreases to 90%, which means the model is trying to overfit on the data set, and while testing, it is not giving us the accurate accuracies. And on the other hand, if we see for efficient net family as a whole, we have good training accuracies as well as the test accuracies. So from here, we have concluded that one of the best model to do this waste classification, to automate everything, we came with efficient net B naught. Now we have also make this graph where we have compared accuracy versus parameters. So we can clearly see like BGG16 has one of the largest parameters, and on the other hand, the accuracy is quite less. Similarly, if we see for efficient net B naught, we have one of the lesser parameters, but the accuracy is quite good, which means if we wanted to if we wanted to make some system having less parameters, having less things, and we wanted accuracy to be much better, we will go for efficient net. Now let us conclude everything that we have just saw. So efficient net B naught is one of the top performer, having the higher accuracy as we have seen, ideal for real world deployment as it is accurate plus efficient. Mobile net V2 is lightweight plus edge compatible. If you see here, we have one of the model which is having one of the less parameters is mobile net V2, less parameters with good accuracy. So what we conclude that mobile net is lightweight, edge compatible, and it is best suited for devices like IoT and mobile devices. On the other hand, BGG16 is not performing as we have expected. It has higher parameter count and yet lowest test accuracy, not practical for real-time or embedded use. Now, finally, what are our future works is we wanted to improve robustness using under varied lightning conditions. So for that, we will use histogram equalization in Clahe, and we wanted to compress our model, like we will use tensor RT and TF Lite for faster lightweight inference on devices like Raspberry Pi, because Raspberry Pi can't have these models because these are very big models. So for that thing, we have to use TF Lite or tensor RT, and we will retrain the model again and again using some misclassified real world samples, so that at the end we would have one of the best models with us, which will have one of the least misclassification error. We will also integrate gas, weight, temperature sensors for enhanced classification. We will also introduce and extend to e-waste, medical, and hazardous materials. And we wanted to connect it in like we wanted to connect into IoT dashboard, smart bins, and urban waste in order to contribute ourselves to the smart city integration. Yeah, that's all about our research. Any questions, anyone?
Nice presentation.
Yeah.
As we are discussed about the edge devices, so can you tell me what are the limitations regarding latency if you are going to use the edge devices?
Yeah. Actually, these models are very heavy. If we talks in terms of, it's good if we are doing classification on Colab, Jupyter Notebook, it works fine. But when we talk about these devices like Raspberry Pi, it's very critical for them to have these heavy models, and for that we have to use TF Lite or TensorRT in order to compress these models to very low MB, and then we can do classification. This is one of the limitation that we have also encountered while doing one of the projects, and then we use this TF Lite library to compress this model.
Okay, thank you.
Yeah, okay.
Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon K. Shalaja with the paper titled A Novel Explainable Hybrid Framework for Temporal Risk Prediction and Anomaly Detection in Diabetic Disease Using Multimodal Health Data. Ma'am, if you're ready, then you may start with the presentation.
Yes, ma'am. Am I audible?
Yes, ma'am, you're audible.
Thank you. Is my screen visible, ma'am?
Yes, ma'am, it is visible.
Yeah. Well, good morning, everyone. So myself, Dr. K. Shailaja. So I'm going to give presentation on my research or proposed method, a novel explainable hybrid framework for temporal risk prediction and anomaly detection in diabetic disease using multimodal health data. So these are the contents that I'm going to discuss now. So the motivation of the research problem that we have defined, and a small introduction to the research problem, and what are the existing work which has been done till now. The proposed model, why we have used that hybrid model, and the experimental data and future conclusions and future work of the research I'm going to discuss. So as we all know that.
Excuse me, ma'am.
Yes, sir.
I'm sorry to disturb you, but can you put your PPT in a slideshow mode?
Yes.
Yeah.
Is it now slide share mode, sir?
No, ma'am, it's a Word document.
Yes, sir. How is it in slide share mode, sir?
Yes, ma'am, now it is. You can please continue.
Yes. So related to the problem statement, that as we all know that the diabetic disease is becoming increasingly critical health issues across the globe, or that demands early diagnosis and continuous monitoring. So the main focus of our present research that we are designed a hybrid framework that combines deep learning based temporal modeling with the classification machine learning supervised anomaly detection algorithms. Mainly, the framework utilizes the multimodal data sources, including electronic health records, and wearable sensor data, and robust diabetic risk assessment. Why we have introduced the explainability in this means, because as we know, we are developing a model related to the medical imaging. So if the clinicians has to trust the model, somehow we have to give the interpretability and explainability about that. So we have introduced the model called explainability, so that we have achieved using the shapely, additive, explainable, and counterfactual reasons to provide both the global and local interpretability. So what do you mean by the interpretability? We will be knowing very shortly. So as we all know that the diabetic is a very common condition that affects people of all ages nowadays. So why this happens in the sense when your blood sugar levels or glucose is too high, or it also what you call as develops a pancreas which does not make enough insulin or at all. So when the body is not respond to the effects of insulin, we are going to get a symptom called the diabetic. So as per the statistics which are given by the International Diabetic Federation, so it reports that around 11.1% or 1 to 9 of the adult population which are under the age range from 20 to 79 years is living with a diabetic in 2025. So with an over of 4 in 10 aware that they are having this kind of disease. So this is we have considered this is a critical problem, and also they have given by 2020 the projections will show among 1 in 8 adults, approximately 853 million people are going to have the diabetic. So which is increasing almost a drastic increasing in the percentage like 46%. So they also suggested what is that IDF also suggested that if we can reduce the impact of the diabetic by taking preventive measures and proper care, and mainly the early diagnosis. So this is the main motto that we have taken this research problem so that we can identify the disease at early stages so that we can decrease the effect of this diabetic in future. So generally the traditional methods which are used to detect the diabetic is what in the sense many the people have to go to the diagnostic centers and they have to give the blood sample, and accordingly they are detecting whether what you call as a diabetic disease are there or not. So this makes what actually the glucose, the plasma glucose, or some different tests are available. So what we have seen in this particular research is many traditional methods which currently in use are time taking, and they are also fail to detect this early. So if you detect this early, as I already said, we can decrease the effects of this particular disease. So that's the reason to address these particular issues. The traditional models can be extended using AI by recent advances, which shows the prominent results in medical field to detect the and classify the diabetic disease. So that's the reason many existing research works have extended the traditional models using general ML algorithms like linear regression, support vector machines, and which are the models which are developed are giving good diabetic results or good accuracy. But what is lagging here is all the ML models that they have designed are black box in nature. So because they will not give any explanation why the model is giving this kind of performance. So it is a challenging for the doctors also to understand and trust the ML models. So due to this lack of explainability and interpretability, the clinicians do not practice this ML models which the existing research developed. So to predict this diabetic disease. So that's the reason recently the explainable AI has come into the research in medical imaging. So which is very transparent and reliable in detecting the risk of the diabetic disease. So your explainable AI models such as SHAP, LIME, and Deep Lift have been developed to interpret machine learning models for clearly mentioning the contribution of each feature. So mainly why we are using this explainability and interpretability in the sense we are giving the weightage of each feature so that your model is giving this much accuracy. So the current research proposes an explainable hybrid model that incorporates time series modeling to ensemble prediction and novelty detection to improve the diagnosis and provide interpretable results. And many researchers have developed, as I said already, with the normal ML, general ML models, and as well as the deep learning models. So many research advancements have been going on the diabetic research disease prediction. So, for instance, the alliance which has developed an early stage diabetes by leveraging the predictive capabilities of multiple supervised learning algorithms like SVM and um, linear regression models. And one more researcher called Sayhood et al. Presents a practical three-stage framework utilizing the ensemble machine learning technique to enhance the diabetic prediction accuracy. And one more researcher called Hari Krishna employed a neural network because they have all developed and somehow used that explainability. But what they are lagging here is the existing framework uses all what you called as a static electronic health records data. So ignoring what? Ignoring like your time series signals, time series data in the sense that is a continuous glucose monitoring. So that's the reason what we require. The early studies are using SHARP and LIME, but they have employed a static data models like a linear regression, random forest, like that. So that's the reason what we need here. We need to combine that individual models so that we can analyze that glucose trends, how that glucose trends are going on in a particular patient, so that we can give interpretability results to the clinicians who can trust and support the predictions which are done by the machine learning and what you call as a deep learning models. So that's the reason we are combining a multimodal health data through a hybrid framework that combines deep learning, machine learning, and explainable AI to improve the detection of temporal risk anomalies in diabetic patients. So, if you come to the proposed work of our research problem is, so here what we are doing here, first we are, collecting the health record data from various sources. So various sources in the sense here we are mainly concentrating on both static and as well as what the temporal data, which is giving what you called as a continuous monitoring of the glucose in glucose in a patient. So mainly we have collected multimodal health record data, so which we have seen which is a data set which is available for the diabetic research is PIMA Indian database. And we can also have some other data sets like MMI3 EHR dataset. So both of this data are considering the what you call as a base line modeling data like a
Excuse
static
me,
data.
ma'am.
Yes,
I'm
yes.
really sorry to disturb you, but I'd like to remind you of the time limit.
Okay. So temporal health records. So the next is your temporal modeling. So what is the purpose of this temporal modeling is to capture evolving trends in time series data like glucose levels, heart rate, and vitals. And then we have whatever the data, output given by your temporal model is given for your supervisor learning. And here we have used XCBoost to classify whether the patient is having a diabetic disease or not. So it's a binary classifier here we have used. And then we have seen this anomaly detection. So where this anomaly detection has been done with the autoencoders. So like that. And once whatever the anomaly in the sense, here we have taken different types of data like a patient which is having what we called as a diabetic a patient who is not having. So accordingly, if is there any what you call the outliers which are there in that, so we are going to find out that anomalies by using autoencoders, and then what we are giving this anomaly detection has been done with the help of your explainability AI. So this is how your what we called as autoencoder model is going to give the output. So here I have taken a different samples from the patient who is having both what we called as a diabetic and non-diabetic data. So different number of samples, and in each case we have constructed a reconstruction error, and the reconstruction error with the minimum value called 0.2 is consisting with a non-diabetic patient, and which is consisting a reconstruction error which is very high is representing to like 12.5 is we have observed is a patient who is having the diabetic. And then the results which we have produced are, compared with the existing works also. So XCBoost, which is giving a very high accuracy compared to the existing, which is 97.2, and the precision and recall and F1 scores are related to that XCBoost. and LSTM model. So the LSTM model, as I have said, which is taking the both what you called as a static and temporal data. So on that, which is giving an accuracy called 96.50. So which is high, which is very high compared to the existing work. And the main thing here, we have used Shapely Additive Explainability AI. So which is giving what, depending on this given features, glucose, BMI, age, insulin. So what is the, what you called as the impact, or what you called as a weightage of each feature, so that you can detect a patient who is, or predict a patient who is having diabetic or not. So these are some values, and this is the clinical insight we are giving. What is the model, why it has given this glucose as a high weightage for the feature, and accordingly what is the conclusion clinicians or a doctor can take depending on these features which we have observed in our PIMA Indian data set. And this is the, summary I can say. So see this. So depending on this values, I can say these are the features which are having a weightage on that, so that we can finally predict the diabetic, whether the patient is having a diabetic or not. So various features we have taken, and the graphical representation of that also we have. So this is also combinedly we have taken, and I can say this is the summary of the sharp values which we have taken for the PIMA data set. So this is what the blue line will represent it as a low value, and a high, this is the color, and this is a feature value, and how that feature is impacting the detection of the disease. So finally, I can conclude that the present research demonstrate a novel integration of the predictive model, explainable AI, and anomaly detection for diabetic risk prediction of the PIMA dataset. So the main core idea of this hybrid model is to focus on training auto encounters on non-biotic data to model the normal distribution of the patient data, which additionally uses an unsupervised classification algorithm like XGBoost to enhance the decision making based on the learning latent representations. So the proposed work not only improves the accuracy, but also enhances the interpretability and the clinical trustworthy of the model. And the future work we can also focus main expanding the data set scope, such as integrated time series, continuous glucose monitoring, and deploying the model as a real-time clinical decision support. So we can also apply some pre-processing methods in time series, because the present work we have done only on the static data, the pre-processing techniques, but you can apply some pre-processing techniques which are efficient on time series data, so that the model does not involve any learning, which is ideal for the real-time applications. So this is what the presentation, these are some resources and references we have used.
Nice presentation, ma'am.
Yeah, thank you, ma'am.
I just want to know that, am I audible?
Yes, ma'am. Yes.
Yeah, I just want to know that for explainability, do we directly require sharp algorithm here, because correlation can also give the similar results as well.
Yeah, so but correlation will also give the similar result, in the sense it will be working only with the static data that we have taken. So because continuously here we can monitor some like 7 days or some 15 days duration, the glucose level of the what you called as a patient. So where that correlation is not giving that much accuracy. So that's the reason we have employed this Shapely explainability on this diabetic detection.
Okay, thank you, ma'am.
Thank you.
Thank you, ma'am. We'll be proceeding on with our next paper presenter.
Thank you.
Sambram, with the paper titled On Location ADR Recording, Advancements and Challenges in Real-Time Dialogue Replacement. Sir, if you're ready, then you may start with your presentation.
Yes, ma'am, I'm ready. I'll just share my presentation.
Sure, sir.
Yes, ma'am. Is it visible to you?
Yes, sir, it is visible.
Yeah. So my topic is on location ADR recording, the advancement and challenges in real-time dialogue replacement. The paper ID is 1178. I am the author with my co-author, Dr. Archana Paswan from Amity, Jaipur. So automated dialogue replacement, that is ADR. Before that, 91% movies which is being showcased, whether it's in an OTT or it's in theaters, the audio always recorded separately in this studio. What you are seeing, this is our studio. This is where the audio mostly, this kind of format they record the audio. Audio and video never recorded same time to showcase in a theater. So it is a primary aim to replace or enhance dialogue that was initially recorded on sets, ensuring the clarity, refining actor performance, adjusting the accents. Our paper is going to explore the advancement of technology that is called the on-location radio recording, so that no need to hire a studio once the movie production is over. You can do that online on location. The emerging field of a real-time dialogue replacement, while also examining the inherent challenges and potential future trends in these evolving areas of film and television production. And we have very less literature review we found because there are in fact, no work has been done as per my knowledge concern on this. So there are very limited resources we found to help our LR. And the methodology which we have used here is three types of methodology. First one is the technical analysis. In this, what we have done is we have focused on evaluating the tools, the softwares which is being used. Mostly we use Adobe or else Avid Media Composer. There is the two major softwares which is being used in the industry. And the recording devices, we have taken the Zoom F89 and some of the sound mixers also we have taken. That is our technical analysis to find out the parameters such as audio quality, latency, ease of immigration with video playback matching. Then the second one we have done is the field case studies. We have taken few movies since last 2 years to check that what kind of technology they are using for the ADR purpose. And the goal was to understand that how different crews integrated with ADR techniques under the shooting schedules. It may be inside the studio, it is in outdoor, everything we have taken in this. And the third is the expert interviews. We have taken two. One is from the Indian cinema, and second one is from the French. The two of these interviews we have taken, those are working, one of them as the ADR engineer, and the second one is the post-production supervisor. So these interviews also provided us the equal-evaluative insights of the feasibility, the limitations, and evolving attitudes towards the on-location ADR. So when you did an interview, that what we found is the first thing we found that enhanced that emotional authenticity. So what happens is the positive point of recording ADR, the dialogues on location, after, take an example, after the scene is over, they come inside a truck which is insulated with acoustic treatment is being done inside that. They come and they give their dialogues. The only reason, the better thing is that why it happens comes very nicely, the quality comes good. The reason is that actors are in the character, what the role they are playing. So they know that what kind of tone need to be used. They know what kind of accent need to be used while the audio recording is going on. So both professionals emphasize that the actors deliver more emotionally grounded and believe performances when recording ADR on location, as the physical environment helps them to reconnect with the original scene. And the second one is the improved performance continuity. The on-location ADR allows actors to remain in character, the maintain consistency between the takes, reducing the disconnect often experienced in studio settings. So once our production is over, we take another a month or 2 months to start our post-production. And by the time the actor may be engaged with some other projects, he may not know that what is his character is. So that takes little time for them to come back. And the third is the greater flexibility in production. The technological advancement have enabled spontaneous ADR capture during the shoots, in offering filmmakers more freedom to address dialogue issues without major scheduling disruption. So the first thing is they need to find out a post-production studio. It need to be available. The character need to be, the actor need to be available for the same time for the dubbing. Then the fourth one is the high quality real-time synchronization. So what happens is the portable recording which we are using F89, F8N. So that sync tools have made it possible to achieve near studio audio recording set, streamline the post-production, and that reducing the guesswork in matching dialogue with the footage. When I say footage, means that is the video to the audio. And so what is the traditional? We have compared both the traditional ADR versus the on-location compact studio ADR. The first thing is the parameter, the microphone synchronization accuracy. In the traditional, that's the frame, which is we call the time code TC, the time-based high precision via time code. And on location, that is primarily visual software based on the variable precision. Then the noise which comes from the floor, that the dB, aiming or minus 60 dB inside a traditional ADR, but variable depends on the location or the booth. It will becomes about minus 50. In our research, we find minus 50 to minus 58. And the third thing is acoustic treatment, which is professionally treated in the studios. But when you are going to a compatible truck or also portable booth, acoustic panels is been kept. This is not temporary. We can always remove it. And the key microphones which you use, that U87, TLM 103 and 416, that is a matching the production mics. And but on location, we use the portable shotgun microphone, the lavaliers, and the USB. Lavalier microphones has been used of the most of the Indian television shows, the TV series. They use the lavalier microphone. And the key software for the recording, we use the Pro Tools in the traditional ADR, which inside the studio, Voice Q, ADR Masters, and ADQ. And but on location, we use DAWs that can be up on the laptop or else the mobile ADR apps. There are many apps are there with the mobile applications, which is compatible. And the workflow efficiency, which is setup time, potentially longer time it takes in ADR, which is traditional ADR, which is inside the studio. But on location, it takes very shorter time. In our cases, it is about 65% time saving. Workflow efficiency recording process, that's you need an engineer, while the traditional ADR in a studio, and it's a controlled. But on location, it is an actor lead, remotely directed. Workflow efficiency in the post processing, potentially less if recording quality is high, and put more variables might require more work. So that is a problem with the on location recording. The cost factors, higher cost factors in the traditional ADR, but in the on location ADR which we have implemented, that is very low in terms of flexibility and availability. Lower location flexibility, higher location flexibility in terms of on location, because traditional ADR, what happens is it's a bit difficult to find a studio the time of the available matching with the actors. And this is why we have done this, our experiment purpose. We use, this is our traditional ADR. Generally, what we do is the voice is recorded always separately. If you see the cameraman is holding the camera, but the recording is happening separately. The recording is happening, the audio recording is happening separately. So what happens is the ADR workflow begins during the initial filming, where on-set audio is recorded, often using a boom or microphone to capture the actors, which you can see. And again, depending, sometimes what is human error happens, if the boom operator which holding the microphone, if a little bit shakes the mic, then the audio quality also changed over there. And how our workflow happened over here, if you can see, we have compared the both, which is the traditional ADR workflow and on location compact studio ADR workflow. First, we log the picture, then you spotting session, the director and supervisor sees that which is the perfect shot need to be dubbed, which has the audio, which has the music, they check that. Then they first see the schedule of the talent, when he is free, what time he is free, that they found out after the week of late. And they book the ADR studio, then they record. In the recording also, you need the engineer, the director, and the cast. And again, it will be review and retext if it is required. Then finally, it will go edit and sync in post. Mostly the things are similar. But the third point which I wanted to showcase over here, in ADR workflow, the same day, the talent can have the access to the sound booth, where he can go and give the voice separately for whatever the shots you have given for the visuals. And fourth is we can use a mobile phone or the portable booth plus the laptop can be used for the audio recording. Then the next comes the record. ADR we can record on the set or nearby the set where the small place we need with we can keep the acoustic panels.
Excuse me, sir.
Which we will do.
I'm
Then,
really sorry to disturb you, but I'd like to remind you of the time limit.
yeah, sure, ma'am. So quick review on retext, we go quickly, we go for the review, and then if there is a retext is required, we take the retext, and then finally the edit and sync in the post with the music, so with the background scores that happens in the editing, the final stage of the editing. So this is our experiment. What we did is what we have recorded the shot which you have recorded, and that we brought into the Adobe Premiere Pro. That is where the most softwares the filmmakers they use. If you can see that we recorded a 2-minute audio segment in an on location compact studio setup designed for the flexibility and portability. Simultaneously, we recorded the same duration of an audio industry standard professional dubbing studio. That is in another slide I'll show you. But if you can see, the labels are audio levels are -8 dB. -8 dB is the good audio levels which can be for the broadcast or for the telecast. We can use the good dialogue delivery. And then the next one, what we do is that which is the on ADR, that is we record this in the on location audio, and on location audio, what happens is we can see that the audio level it is showing to the -2, which is showing in the audio track 2, it is showing the -2 dB. We can observe it's a visual characteristic such as amplitude variations. We found out this, which indicates the dynamic range and the dialogue captured in that environment. The audio level is -6. This is the loudness of the track and decibels, providing a quantitative measures of the intensity. The time code at the top helps in identifying specific point in the timeline where the location audio is the reside. So only the difference is coming for the -6 and -2 is the difference is coming while recording on location and hiring a post-production audio studio for that. And the -2 is very, very minimal in terms of the comparison. And that happens due to the completely packed studio with the acoustic performance. That is the only -2 we lost in our ADR on location ADR. I'll go to the conclusion directly. This study's experiment confirms that professional dubbing studios provide superior audio quality due to controlled acoustic environment and high-end equipment, resulting in a cleaner recordings. Our research indicates that professional studio recordings exhibited audio levels 2 dB higher than those from the on-location compact studios. However, on-location compact studio recording offers a viable and often necessary alternatives, capturing the authenticity of the recording environments and making it valuable for creative and narrative purposes. If you see the choice between these two, if there is any low budget movie or the low budget production, they can easily adopt on location ADR, which is much more cheaper, which is more than 65% cheaper in comparison to the traditional ADR recordings. Yeah, I am done. Thank you very much. If there is any questions, I'll love to take this.
Nice presentation, sir. No questions from my side. Thank you.
Yeah. Yeah. Thank you, ma'am.
Thank you, sir. Thank you,
Thank you.
ma'am. This brings us to the end of the session. I'd like to thank our authors. Just a second. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Spinger. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I'd also like to thank our session chair for chairing this session. Talking to the chair on behalf of Team ICT4SD and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Thank you.
Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.
Thank you.
Thank you, ma'am.
Thank you.